So hi, good day. I am Mark Angelo Galvez from Bachelor of Science in Civil Engineering Section 1E. And this topic is all about inclined planes. So in problem involving inclined planes, gravity is the accelerating force, yet the acceleration is not vertical. Objects are known to accelerate down inclines because of the balance force. It is common example of inclined planes are hills and ramps. So like for example, a sled tied to a trees on a frictionless showed covered hill. If the sled weighs 77.0 Newton, find the magnitude of the force exerted by the rope in the slip and the normal force exerted by the hill on the sled. So here is the hill. This is the tree, and so the forces acting on it is this is the force tension, this is the normal force, and this is the weight. And there is a force when an object is on the slope. Most convenient to use tilted coordinates so that, for example, the normal force is in the y direction and the force applied or the additional forces that acts on the object is in the direction where we do not need to use angle. So first, to solve this problem, put the weights that act on the object. According to the problem, the hill is now covered. That's why it is frictionless. In the absence of friction, the hill exerts no force in the sled because the sled is the rest by second law of motion, that there's no acceleration that sled is. So let's draw the free body diagram. So this is the force tension, this is the normal force, this is the weight, the angle, this angle theta, and the component ng x. Normal force is directly placed on the y and ang mag-a-adjust na lang is yung weight. So we are asked to find the magnitude exerted by the rope or the force tension, and another is the normal force. There are two forces are asked in this problem. The normal force is the y direction and the force tension is in the x direction. So we use the two components to solve for that. So let's start for the x direction. So summation of x or summation of fx is equal to mass acceleration sub x. So we have no motion, so that there's no acceleration. So cancel this. Matitira na lang is 0. Ang nag-a-act na lang na force sa x is the, or first we can get the components of weights. So we have two na nag-a-act sa force in x direction. The force tension and the weight or the x component. This is positive. Assuming this is the positive sides. So, 0 is equal to force tension minus the weight. So next, solving for the force tension. For the force tension, F sub y is equal to weight sub x. And F sub y is equal to weight sine angle theta. The x component is sine theta. Why sine theta? Because our angle is from vertical, not from the horizontal. So by substituting the known quantities, so F sub y ay equal sa 77 Newton sine 30 degrees. So if we do the math, the answer will be 38.5 Newton. This is the answer for the force tension. And lastly, for the normal force at y direction. So summation of Fy is equal to mass acceleration y. Again, we don't have motion, so there's no acceleration. And the net force is 0. By summation of forces na nag-a-act as a force on y components, first is the normal force na in positive. So, 0 to. Next is 0 equals normal force minus the weight. So, normal force is equal to weight cosine angle theta. Naging baliktad ang pag-a-apply ng angle dito kasi the angle theta is from the vertical, not from the horizontal. Unlike the other problems na sinolve natin. So, normal force is equal to 77 Newton multiplied or cosine 30 degrees. So the answer will be normal force is equal to 66.7 Newton. This is the answer for the normal force. Unlike its value on horizontal surface, the normal force is less than the weight of the sled. When the sled is on the slope, it is because only part of the force of or the weight at the x component that acting to pull the sled on the slope. The y components of a force of gravity or the weight balances the normal force.